Hello everyone, am I audible? Great. Chaliye, it's very nice to see all of you one more time in our session. For the part which I am going to discuss is recursion. Okay, so I welcome all of you for this session where we are discussing C programming, or the probable concept where the question can be asked. And I believe that the part that I am discussing, you will definitely going to find 2 to 3 mark question from this if you cover this entire topic. Okay, so without any further delay, let's start the session and let us try to complete this one of the very interesting and important part, which is recursion. Okay, so are you ready for this? Can we start, everyone? Audio, video, respond something, say something. Are we okay with this? Okay. Now, what we have done yesterday was we have concentrated on the function. I told you every aspect of the function: calling function, calling a function, calling a function. Okay. Uh, then actual parameter, formal parameter, global variable, local variable. Today we are going to okay. So today we are going to talk about recursion. Okay, we are going to DPP नहीं आएगी बेटा इसकी ना, recursion. We'll talk about simple tell recursion and we'll learn the shortcut. We'll talk about non-tell recursion. Okay, we'll talk about non-tell recursion and we'll talk about multiple recursion. Okay, we'll talk about this. Okay, so let us start dealing with this topic, which is recursion. In between, I will tell you one more concept which is also very important and which is nothing but uh, a storage class, static storage class we'll discuss. Now, what is recursion exactly? Recursion is a problem solving technique. Okay, recursion is a problem solving, it's a mathematical thing, a problem technique in which solution of a problem expressed as smaller instance of same problem. Okay, so now understand that recursion is not as old as its mathematics. Okay, it was not a programming thing, it was a mathematics thing, and it came early, before programming. So now let's say has a lot, not having a very no history. Okay, so but it is here in this case is adopted for adopted from programming. So it's a problem solving thing, it's a mathematical thing. Okay, now in C programming it takes Okay, in C programming, it takes a function calling itself. That is why we are covering this part. In C programming, it's a function calling itself, calling itself. Okay, the function call itself is basically a it is not the same case that you will get the same priority. ऐसा नहीं है. You will get the BTech will get the more priority. What I statistics says that there are very less number of student in MTech and more or less from core branches all are placed. Okay, so it's not that it's not about priority. It's about performance. If you simple, they will open the gate. If you can go through the gate, if you can pass the gate, you are in. That's all. So there is nothing that the BTech will get the first priority, or they are allowed and most of the company allowed. Even the recent trend that has been observed by the companies is that the attrition rate, the retaining, the student that join the BTech student which join a company, it doesn't they are not able to retain them for longer period of the time. Okay, so BTech rate attrition rate is higher compared to MTech. Okay, compared to MTech. So BTech students, those who join, they leave they switch the company, let's say 1 or 2, but MTech people they stay there for longer period of the time. Now what is the reason, I don't know, but that is also one of the fact here in this. Okay, so it's not true that the preference thing is not true. Now let's start with a single recursion in this case. Let's start with the single recursion. Okay, single recursive call. Single recursive call. Recursive means a function calling itself. Let's single recursive call, and that let's learn the very simple recursion, that is tell recursion or non-tell recursion and non-tell recursion. Okay. Now, what is this tell recursion, non-tell recursion? I'll give you an example. Let's start with this. If the recursive call is the last statement of the function, let me write here. If recursive call is the last statement of function, then we call that recursion as tell recursion. Okay, so last statement of the recursion here in this. Now here let's have a function, let's have a void fun. This is the function void fun, and that takes an integer value int n, and the first thing whenever we write the recursive function is the write termination. So if n is less than equal to 0, then you can say return. Okay, then you can say return. Else you do simple n is equal to n minus, okay, let's say printf %d, and let's say n, and we'll call again the same function fun, and I'll write n minus, let's say 3, n minus 2. Okay, let's make this later, we'll make the thing interesting. Let's say fun n minus, okay, return and nothing. Okay, now suppose we call the function here in this case is fun 10. Let's call the function here fun 10. Okay, this is the function that is fun 10. Let's call the function fun 10. So fun10, what is fun10? So I am calling the function fun10. Now how to deal with the recursion? If you are learning for the first time, you understand that recursion can be best dealt with tree structure, a recursion tree structure. Okay, recursion tree structure. So now when we say fun10 over here, okay, fun10 over here, when I call 10 less than equal to 0, no, it is not less than equal to 0. So you have a printf 10 and you have a calling of fun 8. Look at here, 10 and 8. Okay, and you have to check this condition always, but I am not writing it. It will be checked. If it is there, it will terminate. So printf 10, call fun 8. Here, if I call the same function, it will check the condition, no return value. So printf 8 and it will say fun 6. Okay, n minus 2. It is not updating. Okay, it is not getting updated. Now, if I say here, then it will be again, there will be a printf statement, printf 6, and you will call the value fun 4. It will be printf 4 and it will call the value here in this case is printf 2, fun 2. It will be fun 2. Now it will have a printf 2 and this time it will call the value fun 0. Okay, so if you can see here, this is the recursion tree for this. Fun10 is calling, I am checking this condition, but I am not writing it in this particular. Now, so this is how the recursion tree will look like. Are you able to follow this tree? Everyone? Did you follow this? Did you follow this, everyone? Are you able to understand this tree? Are you able to understand this tree? Is it okay, everyone? Hmm? Okay, fine. Great. Fine. So now here, once the tree has been constructed, then what we need to do here in this case is to find the output. In any function you want to find the output, then what you do here in this case is do the tracing of it. Okay, what you do? You do the tracing of it, and tracing is nothing but an outer line. Okay, outer line. This is the best way to deal with recursion. It's an outer line. So within this tree structure, I am going to draw an outer line, and whenever there is an action, the output action, okay, outer line I will draw, and whenever printf will come, printf statement occurs, we perform print operation. Okay, we perform print operation. We perform print operation. Okay, so that way we can deal here in this case. So let's draw this part. So now I am going for a tracing, and the first statement comes here in this case is 10. So I will write here the value 10. Then tracing goes to 8. Then I will write 8. Then it's 6, 4 and 2. So 6, 4 and 2. I am giving a space, but actual space will not come. Now after that we will go and it will return like this one. So it's very simple over here that whenever we are drawing, whenever we are dealing with recursion, then a simple tracing and outer line, and there is a logic behind it. Tracing is what? Control transfer. Whenever I say control will transfer, so control will come to printf, then it will go to fun8, then it will come to print8, then it will come to fun6, then it will go to fun6, printf, and then it will go to fun4. So it will be keep on control transfer, and this control transfer can be easily demonstrated or captured by this tracing, and in that case the output will be 10, 8, 6, 4, 2. Okay, this is the tell recursion. Now one very important point that you can observe, and later you can use this one, is a small shortcut. whenever you draw the recursion tree, okay, let me write here this tree, same tree. Let me say this thing very clearly, so later your time will be not wasted and you will be able to answer question related with this. Is this. Now in recursion tree, if the values the printf statements on left side of the recursion tree, left side, okay, if printf then value will be printed in top down manner. Simple. Okay, value will be printed in top down manner, so you don't need to do this tracing. This is the recursion tree, these are the printf statement. So now it will be printed in how it will be printed, very simple. It will be printed in this way, okay, this top down manner. This is the meaning of top down. You don't need to write anything, this is the top down manner. 10, 8, 6, 4, 2. Just draw the recursion tree correctly. Okay, so in the top down manner, and you don't need to do tracing and all, not required. This is the very simple first kind of type of recursion. Okay, now the second category of the recursion is, just wait a minute, give me a second. Yes. The second category of the recursion is called as a non-tail recursion. Okay, non-tail recursion. What is a non-tail recursion? So non-tail recursion is a recursion in which the recursive call is not the last statement of the recursion. So the non-tail recursion is if recursive call is not the last statement, not the last statement of function. Single recursion, but it is not the last statement of the function. Okay, if the recursive call is not the last statement of the recursion. Right? Now let's have an example for it, that how the non-tail recursion will look like. So let's have another function here, and let's have a void bar. Okay, let's call this function as int n, and let's make the thing a little bit more interesting. Let's say let's have a two variable mn n. Okay, now it says that if m plus n, m minus n is less than equal to 0, okay, less than equal to 0, then return. Otherwise, two functions are there, int n. Otherwise, you call the function bar. Let's say not the last state. So first we'll go for the call bar, or I'll say here in this case is m minus 1 and n minus 2. Okay, and then we'll say printf %d two times m comma n, right? हाँ बेटा, पूरा सिलेबस ही कंप्लीट होगा, व्हाई नॉट, पूरा सिलेबस कंप्लीट कर देंगे डेप्थ में, नो इशू. Okay, no issue in that case. ठीक है, चलिए now अब मैं यहाँ पे now here in this case I will call the function let's say bar 4 and 8. मैं ये call I'm calling this function bar 4 and 8. ठीक है, bar 4 and 8 I will call, and this is the m minus n less than equal to 0. That is my function. Okay, m minus n, no, n minus m, n minus m करते हैं इसमें, नहीं तो क्या होगा फर्स्ट टाइम ओनली n minus m minus n minus m कर n minus m. Okay, less than equal to 0. Very interesting, a little bit different. Whatever I discuss always in the YT, something different I am discussing this time. Bar 4 8, and first one is m, this is m, and this is n. Okay, let's execute and let's find out what will be the output. Very simple. First we are going for the call, and then there is a printf statement. Two printf statements are there. Okay, now so now here let's say what is m minus, this is n, this is m. 8 minus 4 less than 0 is not true, so it will go for the call bar, it will become 3 and it will become 6, and then we come to the printf statement and it will print the two value. Acha, can you guess the output? If you are listening to me, can you find the output? Should I give you some time to guess, no, not guess, solve this problem? Are you willing to solve this question? Would you like to attempt this question? Say yes, say no, don't know. I will not say. Are you willing to solve this problem? Would you like to attempt this? At least draw the tree, attempt, draw the tree here. Say something, guys. I know you're listening to me, but say something. Whether are you willing to attempt this question? Draw the tree at least. Anyway, I'll solve this problem. No? Chalo, no response. That means you are not interested. Anyway, no issue. You are not interested in solving, you are interested in learning. Now m and n, so this is m, this is n, so it will print the value 4 and 8. Two value it will print, and it will print like this, 4 8, no space, no space here in this. Now the next time it will call 6 minus 3 is equal to 0, no. So now it will again call the value bar, and this time it will become 2 and 4. And again there will be printf statement, and that printf will be 3 and 6. So 3 and 6 it will print. Okay. The next time it will call the value bar, and it will become 1 and 2, and still 2 minus 1 is not less than equal to 0. So again we will have a printf statement, and that will be 2 comma 4. Okay, comma, why I'm writing comma? I have no reason for writing comma 2 4. Okay. Now next time when you call, the bar value will be 0 and 0. Okay, 0 and 0, and this time the printf will be equal to 1 and 1 and 2. Okay, so this is how it will look like. Okay, this is how the tree will look like. Now 0 and 0, 0 minus 0 less than equal to 0, fine, so it will terminate here. So different things are possible over here. Now we can extend this question, but for the time being, let's say this is my recursion tree. Now in this recursion tree you can see that values are not like the previous tree where all the values on the left side. Here it is little bit different where all the values are on the right side of the tree. Okay, and rule is very simple, that left side then top down, right side then bottom up manner. Okay, you don't need to do tracing and all, forget about tracing and all. Later we'll, for complicated problem, we'll do the tracing. That is the standard technique, but even if you do the tracing, it will come thing like this, bar 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 bar, and then printf 1 2 2 4 3 6 and 4 8. Okay, so here in this case is, if I say the output will be 1 2, then 2 4, then 3 6, and then 4 8. This is the output of the program. This is the output of the. This is what this is called as a, here in this case is non-tail recursion, single recursion example, and in this single recursion, it is not the last statement of the recursion. Pardon me for that syntax error in this. Okay. Now, what we can remember in this recursive problem is this. If the printf statement is right side, if the printf statement, if is right side of the recursion tree, right tree, then printf executes in bottom up manner. Okay, bottom up manner. So this is the shortcut. Okay, if there is a printf statement on this side, left side, execute them in a top down fashion, and if there is a printf statement is on the right side, then execute in the bottom up fashion. That is how this recursion works. Now the next thing, this is very small example. The next thing that that basically now the things will get difficult, and the part they will not ask with a problem with a single recursion. They focus on multiple recursion. Okay, and that is the third category, and that is called here in as a multiple recursion. Okay, so let's talk about this as well. Now, if there are more than one recursive call in a function, if there is more than one recursive call in any order in function, then we call that recursion as call multiple recursion. Okay, then we call that recursion as you can expect 2 to 3 marks here. Recursion, there will be one question, and 2 to 3 marks you can expect from this topic only. From this topic, entire subject 5 to 6 marks. Entire subject 5 to 6 marks. Multiple recursion. Okay, let's see the example, but you have to answer it. Now you have to. I am expecting some answers. Now let's have a function void and bar, and let's have a single variable int n. Same condition, if n less than equal to 0, then return. Otherwise you call bar n minus 1 printf using short notation. You call bar n minus 2 printf %d with n. That is all. Would you like to attempt this question? Okay, would you like to attempt this question? Would you like to attempt this problem? Yes, no? And mine syntax error don't say because fine, I can agree that I'm not running it, but if I run it, I will get the answer here in this. But would you like to attempt this question for, let's say, execution of bar, uh, let's say bar 3 only? Okay, what will be the output in bar 3? Okay, bar 3. So find the output in for bar 3. So find the output here for bar 3. Okay, please go ahead and answer that. What will be the output over here? By that time, let me check your comments. Three value of n is 3. Okay, value of n is 3. Value of n is 3. Done. Chaliye, nice. I need some attempt, because if you attempt it, I'll also enjoy that part. Now, let's see. Let us see. So now we are talking about bar 3. Okay, bar 3. Let's construct, let's make the recursion tree over here. Okay. So now that is a bar 2. Okay. And then there is a printf 3. Okay. Now see, I am calling the function as n minus 1, 3 minus 1, 2, but I am not updating the value. Please understand that in this entire thing, value is not been updated. Okay. Now the very interesting is, next time I will call the value bar 1. Okay. And then again I have a printf that will also print the value 3. So I can see that the last value will be 3 for sure. Okay. Last value will be 3 for sure. Now let's expand this bar 2. So now it will be what? It will be bar 1, fine. Printf will be, in this case, will be 2. And now it will be bar 0. Okay, and it will return. It will not go further. And printf will be again, in this case, is 2. Okay, printf will be 2. What is very interesting here in this case is, and tell me whether if I am wrong. Okay, if I am wrong, then let me know. Do not think that I will be always correct. Now here when I say, it will be bar 0, and when it comes printf, there will be printf 1, and there will be n minus 2, so there will be bar minus 1 this time, and when it is come it will printf 1. Okay, this is the expansion of bar 2. Okay, this is expansion of bar 2, printf 1. Now I can complete my diagram, or I can be real quick smart person. Okay, I can be very quick here, and I can be real quick smart person also here. What is why I can do, why can expect some smartness? Because there is still bar 1 to be expanded. Okay, to be expanded. So now what I can do here is I can use this result to this. I can reuse the result. I can take the value from here and I can reuse here. Or if I want to I am a person which work, I know the hard work, then I can expand it. Smart work, hard work, whatever you want to choose, you can choose. Now the predicting output. Now in this case, when we are predicting the output, what becomes important is the tracing part. Here you cannot say, sir, left side, right side. So there is no left, there is also middle also. Okay, the left, right and middle. So now the things will become a little bit tricky. So I need a tracing here. So tracing does very simple thing, that you have to just draw an outer line like you have done in your childhood. Okay. So first is printf 1. So I will say 1. Bar minus 1 will terminate. Printf 1 one more time. So this is 1. Printf 2 bar 0 will terminate, 0 less than equal to 0. Printf 2. So 1 1, then it will be 2 2. Okay. Then it comes print 3. So now this is 3. Now comes bar 1, and I can see in bar 1 there is a 1 1 printing. So 1 1 printing, and then finally there is a printf 3. So there will be 3, and now I am done. Okay, done. I am done with this. Honestly, give me your feedback, comment that are you able to follow this particular problem here in this case? Are you able to follow here in this particular case? This is 1 1 2 2, then 3, then again 1 1, and then again 3. Okay, 1 1 2 2 3, and then 1 1 3. Okay, 1 1 2 2 3, then again 1 1 3. Are you able to follow? So I got one student who is very good, very good. Okay, great. Okay, Pranav. We'll meet you. We'll meet you from 27th. 27th batch is starting. Okay, great. Now, there is when we do deal with recursion, we have to be careful with one situation, which is called and which has been tested many times. No, it's not it's just it's some session for those students who don't want to join particular course, and we in PW are very much committed for free learning, and so if you are willing to learn from, there are many, it's not that this is only content, there are many such contents are available in Hinglish channel, but this year we started to provide the content for English channel as well. Okay, so this is the, and many or more series will come for theory of computation, compiler design, more series will follow. Okay, so this commitment from the PW to have the free education, or those who are not willing to pay and they still want to learn, so we have so much content in our Hindi channel. So English channel also we are populating with such free content, so that you can learn from here if you are not willing to pay. Okay, now in recursion, let's have one more recursion here in this, and I'll call the function as, let's say, void who and int n. Same condition, no, do not worry, if n less than equal to 0, then return. Then here I call the same function foo with n minus minus, and then I say printf this one. Look at this function and let's look at this situation. But a Kannada channel is, how is it possible? Your engineerings are not, examinations are not in this language, regional language. There is no examination. So even if there is a Kannada channel will be there, then I personally believe, if you want my opinion, I still believe that you should learn in English. That because your examination in English, so you should learn also in English. So that is my preference. But if it is the students are not ready and comfortable, then yes, then you can take the route of regional language. But still no, nothing is available right now. Okay. So now if I call the function here in this case, let's say foo3. Can you predict the output foo3? Let's say foo3. Foo3. It's a dummy name. There is no. They started it. The gate authority have started with this name foo and bar. Okay. I also find it very funny first time, but now I find that yes, that any random function they want to say name, they can name it as foo and bar. They started it. They started this naming convention. Okay, anyone with output, what will be the output here? N minus minus, it's a post decrement operator. Anyone? Very good, huh? Very nice, huh? N minus minus, what is this? This is the post decrement operator. Okay, it's a post decrement operator. So now here, if I just ask you, and let's make the thing interesting, a little bit of interesting. Let us execute this code. Let's execute this code here. Let's execute this code. Let's make this a bit more interesting. Can I do it here? Yes, I can do it. Can student also see my machine? Yes, they can also see. So look at here. Look at here. Let's make the thing interesting. Let's have this function as void foo, void foo, and we have int n, and we have a condition, as I said, if n less than equal to 0, then I say return, else you call the function, the same function foo, n minus minus post decrement, and you come here and then say printf, okay, %d, and you pin the value of n, and let's call this function as foo3, okay. And I'll explain you what happens here. First, see the result here, and the semicolon is missing, and everything looks correct apart from that. See, now it says that program finished with the exit code 139. Okay, it says it is printing. First of all, observe that output it is not printing anything. Okay, output it is not printing anything. So nothing will be printed here. Okay, and it says that exit code 139. What is this exit code 139? Okay, now let's have this statement exchanged. Let's do the first, we do the printing and then we go for the call. Okay, let's do opposite. First print and then call. Okay, now see, 3 been printed, and then after that sometime, how many 3? We don't know. How many 3? We really don't know how many 3s are there. Like here, and after that exit code 139. So plenty of 3s are there. Okay, so now two issues are there. Why it is printing 33333? Why the values is not getting updated? Okay, why it is printing only 3? Always the n values. Why n value is not changing? And what is this error code 139? There are plenty of 3s are there, and we cannot count it. There are so many 3s are there. Almost 3 to 4 pages, only 3 is written. And what is 139 here in this case? Yes. So now let's come. Okay, so now here in this, what is the error code 139? Two things we need to figure it out. Okay, so now if you have noticed or if you have any understanding of the system, then you will identify that the system itself is having a runtime stack. So what is this runtime? It's in main memory. Runtime stack is, or whenever you do the function call, this stack, runtime stack, is responsible for execution of function and recursion. And every time you call a function, the content of the function, the information of the function is pushed into the stack. So foo3 is going to call what? The problem is that foo3 is going to call foo3 only. Okay, why? Because post decrement 2 uses, it will pass the old value but it will decrement. Okay, it will pass the old value but it will decrement. So now what will happen? There will be sequence of call foo3. Every time you call the function, it will foo many times 3. As you can already see that there is a many time foo3, and it will fill this runtime stack. Okay, and it will completely fill the runtime stack, and after that it will cross the limit of the memory. Okay, so it will completely fill. And breach the memory. Breach means violation. Breach means it will be in violation, and the moment it will try to write in other space, okay, it will generate the segmentation fault. So error code 139 is nothing but the segmentation fault. So first time when I wrote the program, no output will come. Why? Because this statement will be never reachable. Okay, this statement will be, you will be never able to reach that stack. Okay. Second time when I have written this function, what I have done is this. Second time when I have written this function, I have exchanged this two statement. This why I have done this. I have done this. What I have done is this. I have written printf first, and then I return foo, same thing, n minus minus. Now you can see here what will happen, that there will be foo3 will first print. So it will be printf3 only. Then you call for foo3. Then again there will be printf3. Then you call for foo3. Then again there will be printf3. And then there will be call for foo3. So now again your foo3 is calling foo3 only. So again your runtime stack will be executed, but this 3 will be keep on printing. So first program when I have demonstrated, nothing will be printed because control will never reach to where? Control will never reach to this printf. Printf will be here, but foo3 will call foo3. It will stuck here. Next foo3 will call again foo3. It will stuck here. So now control will never reach to this printf3. Okay. Control will never reach to this printf3. It will keep on going into the depth till memory breach. But here it will first print and then go to foo3, fifth print, then go through. Again, both the cases runtime stack will off. Now, here it violates the memory. This is the stack overflow. Okay, this is called stack overflow. Okay, stack overflow. It exhausts the memory and it terminates unexpectedly. Okay, unexpectedly. Okay, so it will terminate. Okay. Okay, let's solve one question where this we have already done. Okay. So let's have one question. Modulo and division. Okay. So void again foo, no terminology. Maybe the last question. INTN. If n less than equal to 9, return n, else return n modulo 10 plus n modulo 10 plus foo n divided by 10. Okay, plus foo n divided by 10, and let's have this value int. Okay, n modulo 10, n modulo 10, n divided by 10. Okay, return value. Now question is, what is the output of foo 345, 245? Output, you have to return value, you have to find the return value of foo 245. Now if you can answer, what will be the return value of 245? Demon John, sir, 2010 CS website कब सितंबर अक्टूबर में आती है बेटा, सितंबर और अक्टूबर, सितंबर या सितंबर में आ जाती है, सितंबर तक आ जाती है, अक्टूबर के आसपास भी जा सकती है, सितंबर एंड तक भी जा सकती है. IIT Madras this year for you, and it is going to be the one of the very interesting paper of last 10 years that I believe. Okay, I really believe that IIT Madras is going to do wonders this time. They will create a very good, very solid paper. Answer, what value it will return for foo 245? How can I say that calculator modulo operation is giving wrong answer? I don't think so. It should not happen. Okay, it should not happen. N modulo 10, n modulo 10, and function this. So let us solve this problem. So now if you call foo 245 less than equal to 9, not correct. Okay, let's write here. So now 245 not correct. So now we'll get the 2 times n modulo 10. So now modulo 10 will be what? 240. So that will be 5 plus again 5 and then plus I will call with foo 24. Okay. Now for 24, 24 less than equal to 9? Nope. So what it will be? Modulo. So it will be 24 modulo 10, 4, then plus again 4, and this time foo will be calling the value 2. The value 2, when it will be called 2 less than equal to 9, then return n. Okay. So now here it will be 5 plus 5, 4 plus 4, and this value will return in this case is 2. Okay. So my answer here is 2 times modulo 10 and 1 time n by 10. So the quotient part is 24, modulo part is 5. So 5 plus 5, 10, 10 plus 8, 18, 18 plus 2, that is equal to 20. The value that it will return is 20. Foo2 will return 20. So it will become, the return value will be in this case is 2. 4, 4, 8 plus 2 is 10, or 10 plus 10 will be equal to, here it will be 20. Answer for this question is 20. Okay, answer for this question is 20. Fine, everyone. So now we are coming to the end of this today's session, and I hope you enjoyed the session. All basic fundamental thing I have covered. Some interesting problem we have discussed, and you can take the screenshot of this problem and try to attempt this question, and answer will be I'll be giving you tomorrow. Okay, take the screenshot of this question. Take the screenshot of this question, and I will discuss this question tomorrow. Tomorrow agenda and topic will be pointer. Pointer. I will see you at 6:30 p.m. Okay. Thank you very much for your response, support, and please follow the channel, and I will see you tomorrow. Thank you all of you guys. Good night, everyone.